All right, we're getting close to the end of the chapter. Is there another? I think there's one more lesson after this. Is there one, or is this the last one? Is there 8? Okay. Yeah, one more lesson. Oh, yeah, I know which one that is. So now we're going to do inequalities, and the last lesson we're going to do inequalities as well. And these are called compound inequalities. So instead of just what we've been doing so far, is you just have like x on one side is greater than or equal or less than or equal or whatever to some number, right? Every one of those answers I read off to you was just x is greater than or x is less than or something like that. This is going to be a little different, all right? You're going to have a couple different things. That's why it's compound, okay? It's a combination of things. So we have two types of inequalities we're going to talk about. One word, we're going to use and. Sometimes they use the word and sometimes they don't, but I'll show you when it is and. And you also have another one, it's an or inequality, all right? And here's something they do on the last example. They use this symbol, and I haven't seen this in a long time. I have seen this way back, probably, I don't know when I learned this. But anyway, if there's a symbol right there that represents and we call this an intersection. So it's an intersection. We'll talk about what all this stuff means in a second. Let me just write it down. And then we have an or, and that kind of looks like a V, and this is a union. All right? So we'll just do some examples. We'll kind of explain what I'm doing with the intersection and union as we do the examples. Is that all right? Yeah. Examples seem to always make things a little easier. Okay, so let's just go right to the example, and then we'll kind of, within the example, we'll talk about what this stuff means. It says solve. Whoops. Solve. And here it is. It's going to be 5x plus 9 is less than or equal to 24. But then they put the word and. All right, that's this one right here. It's an intersection. And you'll see when we graph this what I mean by the intersection and the union and all that good stuff. Minus 7 is greater than 14. So right now, it's basically just two separate problems. All right, it's basically just two separate problems. But when we graph it, the graph's a little different than what you graphed earlier. All right, so let's just do these just normal. So I'm just going to look at this as one problem. I'm going to look at this as one problem. We'll look at our solution. We're going to graph it and then determine what our real solution is. I'll show you what I'm talking about. So minus 9, and all right, what's that? Is that 15, right? So 5x less than or equal to 15. Divide both sides by 5. So x is less than or equal to what? 3. So we'll keep that right now. It's not like my final answer or anything, but I'm just putting it in a little box, hold it for safekeeping, and then we're going to use it in a bit. Let's do this one. Add a 7 to both sides. This is nothing new that we're doing right here. Same stuff. It's Algebra 1 kind of stuff. It's negative 3x greater than 21. Divide by negative 3. It is an inequality, and we're dividing by a negative. So what does that tell you? Flip the what? Inequality. That's right. Okay. So we get x. Instead of greater than, we're going to flip it. Change the direction of the inequality, and we get negative 7. We'll put that in a box. What I want to do is I want to find all the values that are both, okay, less than or equal to 0, and also at the same time, all right, or an intersection with x is less than negative 7. So I want to find all the numbers that that's true with. All right. Let's draw a graph. So we're going to keep that right there. Draw a graph. We don't have to be like really specific with this graph. We don't have to like fill in every single number. We're good to go. All right. So watch. Negative 7 we'll put right here. 3 we'll put like way over here. Zero's somewhere in the middle. I don't even care where the 0 is. All right, but that's what we got so far. And let's go to a different color now. Now, how would I graph? What I'm going to do is I'm going to graph above it. You'll see what I'm talking about, okay? So I'm not going to do it right on the graph. Our final answer will be right on the graph, but I'm going to graph above it because I just want you to see what's going on, okay? X is less than 3, so, or less than or equal to 3. So what would I do at that 3? What kind of a dot would I put? Open or closed circle? It's closed because it's or equal to. And then everything to the what? It's less than or equal to 3, so it's everything to the left, all right? You okay with that part? Yeah, that was easy. Now, let's graph this thing. X is less than -7. So what kind of a circle am I putting here? Open circle. And which direction am I going on this one? I'm going to the left again, all right? Actually, I'm going to extend that red one. You don't have to go right to the end of it. I'm just doing it just to make it look pretty. That's the only reason. Yes?
Is it like, when you do like the compound inequalities that like, it has to be something in common?
That's what we're going to look at. Doesn't have to be something in common, but when you have the and, you're absolutely right. Because what word did we use with the and? The intersection. This is where we're going to do that, okay? Where do they intersect? Where do they have numbers in common? All right? That's going to be my final answer. And I'm going to do that in a different color. We'll do that in green. Okay? So, look what numbers they have in common. What about the numbers like between -7 and 3? Are they in common with both of them? No. So the and, I'm going to put and right there. So they would not be included. Where does it begin where they overlap each other? At the -7. That's correct. Okay. Is it so the blue does not include -7. So do we include the -7 with the red one? Is that part of the intersection? No, it's not. But it is everything where? To the left. All right. So all this stuff. See how all this is overlapping? All right, that's going to be the intersection of those two. It's where they meet up. What word did you say? You said you had a word in there. I used it. I don't know. I forget what you said. But anyway, it's where they have the same values. All right. So where do they have the same values? Everything from where? From -7 to the left. Okay. So my final answer is which one? Is it all three of them? It's just the bottom one. It's just the green one. It's where they intersect each other. So when it says and, we're showing where they intersect. Okay, or is going to be different. But when you see an and, we only pick where they intersect. What they have in common. All right, the points that they have in common. What points do both of these graphs have in common? Well, everything to the left of -7 is in common. -7 is not in common because it's not in the blue. It's in the red, but it's not in the blue. Which ones do they have in common? Everything to the left of -7. Or how do we write it? X is what? Less than -7. So that, I'm going to circle it, that's my answer right there. Okay, that's the answer. On this particular one, they don't say to graph it, but the graph I think is very useful. Okay, it's very, very helpful to us. Even if they don't tell us to graph it, all right, I think it's helpful to graph it. Let me see the problems that I'm going to give you. Do they ask you to graph?
Yeah.
They probably do. I would guess they would. Yeah, like 9 to 14 says solve and graph. So yeah, I would definitely graph. The examples are not asking you to graph, but they do it anyway. All right, but there we go.
So if they don't, like, so let's say like they're going this way.
Yeah, that's a different one. We're going to get to that actually not now, in the one after this one. Okay, so we are going to get to that one. She's absolutely right. You see what she did? What if one's going this way, one's going this way? They don't have anything in common, do they? All right, so that's where we use this one, the or the union. So what we would do, we would take a combination of all the ones that go this way, all the ones that go this way, right? And we would put them into one inequality. We'll do that. But we're going to do another and one. But this one doesn't actually give you the words and, right? But the way it's written, it's going to be an and function. It's going to be an intersection function. So let's turn this back to white. And let's do another one. So this one is example 2. And let's write it out. Again, it says to solve. I'll write it out, solve. 8. Now this looks a little different. This is where it really looks like a compound inequality. All right, this is what I think of anyway when I think of a compound inequality. This has some similarities, right? But it's got a huge difference. What's the big difference between this and everything that we've been solving? Well, yeah, there's no separation, right? There's no and in it. It's not just one, but it actually is 2 different inequalities. So when you see something, what this means right here, to see how the less than, you got a less than here and a less than there. What this means is that this value is between 8 and 18. Okay? That's what it means. That means this is between 8 and 18. But what we're going to do is we're going to write them as 2 separate inequalities. All right? The first one is going to be that. Okay? So I'm going to write it separately. I'm going to write x is less than 5x minus 7. Everybody see that? All right. And if you wanted to, you could put a big old and right here. Well, you could put a little one or a big one, doesn't matter. Put an and right there. And what do you think our second one's going to be? It's going to be this one right here. So we're going to write that down. So 5x minus 7 is less than 18. So now we're basically at the same place, kind of at the same place as we were on the last example, right? Except it just looks a little different. So they don't put the word and, but if it looks like this, this is a intersection function, okay? This is an and, I shouldn't say function, an and inequality, compound inequality, all right? So when it looks like this, that automatically means it's an and. So there will be parts that overlap. We got to find out what parts overlap, all right? And that's going to be our answer. So we're going to go through and we're going to solve for x. So I'm going to go 8 is, oops, let's not do that yet. Okay. Let's get x by itself. What are we going to do? Plus 7. We'll go fast. You know how to do this. 5x divided by 5. We can do that in our head. So what's that going to be? 3 is less than what? X. But let's not write it like that. Let's put the x first. So if 3 is less than x, read it from right to left. Then x is what? Greater than 3. Let's write it like that. It's just a little bit easier for us to graph when it's like that. I'm going to put in a little box for safekeeping. Then come over here and do this one. All right. So plus 7. That's 5x is less than 25. Divide by 5, so x is less than 5. Put that in a box. So what we're going to do is we're going to graph both of those on one number line and find out where do they intersect, and that's going to be the solution, okay, for x. Then any number within that range, okay, or that domain, I should say, I guess, will work for this x. Not every single number in the world works for that x. It's only going to be numbers between this one and this one. All right, and that's what we're going to do. So now we're ready to graph. Let me just do it right here. All right, so we've got a graph. And what numbers are we going to put in here? Well, we got a 3. So let's put a 3 right there. We got a 5. Let's put a 5 right there. Okay? Everybody with me? So what does this say? X is, and if you want, let's do the same colors. We'll do the same color scheme. All right. This says x is greater than 3. I'm going to put it up here. If it's greater than, it's not equal to, it's open, right? And it's everything where? To the right. This time it's greater than, so everything to the right. What color did I do before? Blue? All right, let's do the 5. So it's x is less than 5. So I'm going to put what? Open circle at 5, and it's less than 5, so it's everything to the left. Okay? What are we looking for, though? We're looking where they intersect each other. Good. Okay? Where they overlap each other, what they have in common. All right? Everybody with me on that? So what do they have in common? Well, this red does not include 3, correct? So really, let's put this in green. So what do we have right here then? This is going to be open, isn't it? Right? Because they got to include both of them. Now, the blue does hit at 3, but the red one doesn't. So the intersection can't, because they have to be in common with each other. Okay, what about here? That's got to be open. But now what do we do? It's just basically, it's all the stuff that overlaps. It's all the stuff, what? Between 3 and 5. Does that make sense on the graph? Yeah. So now our answer, how do we write our answer? Well, we're going to write it so it looks kind of like this, right? Our x is going to be in the middle, our smaller number is going to be on the left, and our bigger number is going to be on the right. That means that that value is in between the small number and the big number, all right? So how do you think we're going to write it? We're going to write an x in the middle. Which way is my inequality always going if x is in the middle? Left or right? Well, no, it goes to the left. It points to the left, right? Points to the left, points to the left. Everybody got that? So what number goes here? 3. What number goes here? And that is the solution to that inequality. What does it mean? It means x could be any number, what? Between, good, 3 and 5. All right? Well, yeah, it could be decimals, it could be fractions, right? Now, if you went whole numbers, 4 is the only one. So let's just try it. Let's see if it actually works. Let's see if this works. So now what's an easy number? We could do decimals, but do I really want to put a decimal in there? So what's between 3 and 5? A 4. All right, so let's put a 4 in for this and see if it works. 5 times 4 is 20. 20 minus 7 is 13. Is 13 between 8 and 18? It is. Now let's pick a number on purpose that's not in the green. 6. Okay, let's do that. So let's put in a 6. 5 times 6 is 30. 30 minus 7 is 23. Is 23 between 8 and 18? No, it's not. So 6 doesn't work. It's not going to work. Okay? It won't. Nah, you can do it on your own. All right? I'm just trying to show you that numbers here. And I could pick, what's my other region where I could pick points from? Anything less than 3, right? Pick an easy number, less than 3. 2. 5 times 2 is 10 minus 7 is 3. Is 3 between 8 and 18? Nope, none of those work. So would you agree that any number in here should work? And if you wanted to, if you really wanted to, you could pick a 3.1, or you could pick a 4.27589. That would be dumb, but you could if you wanted to. And you're going to find that every single point inside that green will satisfy this inequality. That's how we say it in math. We say it satisfies the equation, or in this case, it satisfies the what? The inequality. Okay? That's not too hard, is it? It's a little different. Have you ever done those before? I think in Algebra 1, a lot of Algebra 1 classes teach that stuff, okay? So, again, it's nothing brand new, but, some of you may not have seen that before. Hopefully that makes sense. All right, let's do another one. Now, we did a couple ands, so what do you think is going to be next? An or. So let's do one of those. And you're right, it is going to be an or. Let's see. So this is example 3. Let's see, what's my time here? 14. Oh, okay, I got time. Good. I only got 2 more examples to do, and I think, yeah, there is a 5th example. I'm just going to do the next 2. Let's see. Solve 9x plus, write solve again. 9x plus 6 is greater than 60. And then they got an or. See that? This is a little different. I mean, our math, our arithmetic, our algebra is basically going to be the same. It's just our final answer is going to look a little different than what we've been doing. What we've been doing so far is intersection, right? What do they have in common? So what we're doing now is going to be a union. So we're going to like combine the two things together is really what we're going to do. There's not going to be a commonality to it, okay? So let's do this real quick. Minus 6, 9x greater than what? 54 divided by 9, divided by 9. What's that? 6. So x is greater than 6. Again, I'll put it in a little box. You don't have to do that, but I just like to see it, so it just pops out right in front of me. Let's do this. Negative 2x, minus 14 minus 3x greater than or equal to 11. We get negative 5x minus 14. Let's just do the minus 14 right now. How about that? Add a 14, right? Is that 25? Greater than or equal to 25. Oh, do you see what's going to happen here? Always look for that, all right? Don't miss it. You're dividing by a negative. So what are you going to have to do with this inequality? You have to flip it, right? So it's less than or equal to what? Negative 5. Did I do that right? Make sure you check my math. When I go too fast sometimes, yep, that's correct. All right, now we want to graph this thing. So let's do a graph. And let's put a negative 5 right here. Let's put a 6 right here. And we don't have to fill in with all those numbers. Just put the two important numbers there. That's good enough, all right? Now, look what we're doing here. This first one says x is greater than 6. I'm going to write this right on the graph itself on this one. So greater than, it's not or equal to, so it's going to be open, and it's going to be everything where? To the right. Okay. This next one, I'll tell you what, I'm going to keep it red because we're going to keep both of those. This one says that x is less than or equal to negative 5. So what kind of a circle do we have here? Closed or equal to, right? Or equal means it's closed. If there's no or equal, it's open. And this says less than or equal to negative 5. So this one, we go where? That way. That right there is a union. So our answer is both of these things. X is greater than 6 or x is less than or equal to negative 5. But you need to include both of those. That means my value for x could be anything to the right of 6 or negative 5 and everything to the left of negative 5. All right, there's no common points, are there? All right, they're completely separate. But if we combine them together, all right, then our solution could be anything over here or anything over here. You put them in and you'll find out that that's true. All right, so that's the ones that are going in opposite directions. That's what an or looks like. Okay? It's not hard at all, is it? Do you think? I don't think it's hard. So let's do another one. It's a little different than you're used to. All right, last one. This time, they use that symbol. Remember I put that symbol, that like little upside down V and then the V looking thing? So they use that. This is two parts. So this is part A, and it's example 4. All right, so 2x plus 3 is less than negative 7. And then they put this thing. What does that one mean? That's the intersection, or is it the and or the or? It's the and. And to tell you the truth, even if they didn't tell you if it was and or, you could probably tell once you start putting it on the graph, right? You can see if there's anything that's intersecting. But you got to know which one you're doing, because you could have two things that go in the same direction and your answer would change depending on if it's an and or, right? Because like that very first one, they both went in the same direction, right? But we just picked where they intersected. What if you did the union, right? Then you'd pick from the one side. Anyway, here we go. Let's do this. Minus 3, 2x less than negative 10. Divide by 2. X is less than negative 5. All right, so that's one thing. And then we got this. Yeah, we could probably do this in our head, but I'm going to write it down anyway. So it's 9x is greater than 9. Divide by 9. X is greater than 1. Okay. Okay, now remember what this was. What did this mean? It means what do they have in common? You could probably just look at the numbers, okay, without even putting it on the graph. Look, x, what's in common when x can only be less than negative 5 and it also has to be greater than 1? Are there any numbers that are in common that are both less than negative 5 and greater than 1? There's nothing in common. So if this is an and, do you have anything? Do you have an intersection? Do you have a common points? You have no common points. So what do you think your answer is? No solution. All right?
There's like a symbol that means no solution.
Yeah, they call it empty set. So you could, or the null set. Have you ever heard of that word? N-U-L-L, the null set. All right? You know how British people, if they say we lost 3-0, we lost 3-0. You ever hear that? It's kind of where null comes from, I guess. All right, the null set meaning nothing. It doesn't really mean, technically, if you said nil, it means 0. But this just means nothing. It doesn't even include 0. All right, absolutely nothing. Or sometimes they would write it like this. You ever see that?
Yeah.
You see a set and there's nothing in there. Not a 0 in there, because 0 is something. That's weird, but it. All right, that means the empty set, that means the empty set, that means the empty set. But I think this book is just saying no solution, I believe.
If we were to write like one of those for an answer, for the professor to take off.
No. State the solution, remember. Oh, I was looking at the wrong thing. Hold on, let me look at this. Chunk says no solution. Yeah, they actually, the book likes this one. All right. So if you were to do a problem and look in the back, if it's an odd problem and you had this kind of an answer, that's what you would see. I'm perfectly fine with no solution. I'm fine if you put that little empty set looking thing right there. I wouldn't use that. Okay, and I wouldn't use that. This is a good way and that's a good way. Either one of them are fine. I don't care. Okay? All right, let's do another one and we'll be done. Would you say 14? Is that when we're done? Okay. Right on time then. So I got 2x plus 3 is greater than or equal to 7, negative 7. And then we got this thing. It's a V looking thing. What's that? Is that and or or? This is or. 4 is less than or equal to 5. All right, so let's do this. Are they the same numbers? They're not the same numbers, are they? They are the same numbers. Yeah, okay. So I don't have to do the math again. I already did it once, right? So really, let's just graph it. All right, and let's just... yeah, so let's just graph it, just so we can see. Oh, you know what? It's not the same. It's a little different. Because this was, see these have or equal, and they're different directions as well. So let's just do the math. Subtract 3, what's that? Negative 10 divided by 2. So x is what? Greater than or equal to negative 5, is that right? If you do the math there, right here, add that, that's a 9, divide, so x is less than or equal to 1. So it is a little different. I saw the numbers, but look, see this is less than, this is greater than, this one's greater than or equal to, this one's less than or equal to. So they are different. So let's graph the thing. So what's my smallest number? -5. My bigger number is 1. All right, and let's see what's going on here. So x has to be everything greater than or equal to, right? So which direction would that one go? It would go that way. And then
okay, Junior,
x is less than or equal to 1.
And you've not received it and you've paid for it, please come to the office. Thank you.
Now remember, is this an and or an or? Makes a difference. It's an or, right? So what numbers can you use? Any real number, exactly right. All of them. You're right. All the real numbers, because we're including all the numbers that go that way and what? All the numbers that go that way. There are some common numbers there, all right? But this is an or. So all the numbers this way, all the numbers that way, which means there's no gap, right? We're talking about every single number. So what's our answer then? It's all the real numbers, okay? So you could just write all the real numbers, or you could do that fancy looking R thing, right? I put 2 bars and then an R like that. Okay, that would be fine. This is what the book does. The book puts that symbol, but if you write all the real numbers, I'm perfectly fine with you writing that. And that's it. What do you think? It's not too hard, is it? A little different. Let's see, what's your 9 to 14? 17, what, 24? 24. It's right here. I gave you paper too, didn't I? But yeah, all my lesson plans are on RenWeb, so you can always check on RenWeb. It's pages 36 and 37. Pages 36 and 30. So there's 3 different places where you should be able to find your homework. One is right here, okay? One is on RenWeb, right, or on Fax, because you can always go to, is it under what? Homework, or is it under homework? Okay. And then you could look at that paper I gave you on Monday, right? I gave everybody a paper on Monday with all that stuff on there. So there's no excuse not to know what your homework is at any time. Would you agree with that? Yeah, no excuse. So there you go. All right. So have that finished for tomorrow. We'll go over that. And then we got one more lesson on this. So what are we looking at pretty soon here? Test pretty soon, okay? We may have another quiz before the test. Okay, probably. Yep, so, but next week we're off for the retreat thing. And that Friday, what do we have that Friday? What's that Friday? Is it teacher orientation or something, or whatever you call it? Okay. So I'm not sure when the test is going to be. We're going to have to navigate through all those days we have off, but we'll figure it out. Okay.